There we go.
Great. Hi, everybody. Welcome to the June U.S. RIG meeting. We have a great selection of student projects today. I'm really happy to be hosting so many different students who've been working in so many different areas, giving us some insight into work they have been doing mostly all over the last semester. Some of them are following up on work that began even earlier than that. And this is a combination of co-op work and work that happened on campus, and people who maybe had personal interests and got projects started, and then continued them. So really excited because this is really the culmination of everything that a research interest group should be. So thanks to all the faculty people and the Red Hat people and the students who collaborated to make this happen. We have 4 short talks, 15 minutes each, so try and stay within your time limit so that we don't go over. And we're going to begin with a group from UMass Lowell who are speaking on the knitting web application. This is Kelly Lee and Erika Salas and their mentors, Paul Downen and Professor Aman and Redlich. I'm sorry, I probably butchered your name. I apologize. So if you want to go ahead and share your content, if you have any content to show, and start sharing your presentation, that would be great.
Hello?
Hi, we can
okay.
hear you and see you.
Okay, good. All right, so hello, my name is Erika Salas, and we will be presenting our knitting web app project today. First, allow me to introduce our team. So our team consists of, as you mentioned, our mentors, Professor Amanda Redlich and Professor Paul Downen. Kelly and I are the student interns who worked on the project. We also wanted to give a special thank you to Red Hat for funding this project. Without them, it honestly wouldn't be possible. Okay, so on to what we created and why. As you may have guessed by our title, we created a program that would help knitters design their pattern. Here we have 3 comparisons of what design would look like for a knitter. First, we have our analog version, which is just knitting by hand. So depending how familiar you are with knitting, this is a process that knitters undergo when they want to create a piece. Usually, they create the design by drawing it out on a simple piece of paper. One of the main issues this brings is that they're not able to color match the yarn, and they can't really play with the gauge. It's just what the graph paper has. So our solution aims to fix that. So we wanted to cover that and also make it accessible so that the user can create a design and make it portable by making it a web app. So on our next slide, we have our Figma prototype design. This is the first main window. This allows the user to input their desired specifications for the grid. Like I was mentioning, the gauge, pick their color, create their palettes. On our second window is our design canvas. This is where the user can create, save, zoom in on their design, and even swap out their color palettes. On our final window, this would be the export window. We made it simplified so that they can have multiple export options. So let me hand this off now to Kelly so she can give you a quick demo of our program.
Awesome, thanks Erika. So this is the beginning of our program. So here's our demo. So we took the design from our web prototype and we were able to implement it to the best of our ability, and we actually added some extra things as well. So over here, you can go ahead, this is a start page, basically. You can go ahead and choose a canvas size. So you can select how many columns and rows you'd like to have. And as Erika previously mentioned, you can also enter the gauge. So this is something special that you wouldn't be able to do on graph paper, in which you can enter the number of stitches in rows for what you'd use a 4x4 swatch. So basically you would knit this much and you see how many stitches and rows that composes, and this basically gives you your gauge, and we use this to calculate basically like the ratio and the size for our grid squares. Over here are some different palettes. So these are ones that you can save off by yourself. So these are the ones that we previously created, and you can also go ahead and create some more palettes, which is something again you can't really do like manually. So these are like, let's say like you have these different yarn colors that you really like, these different palettes that you found online, you can pretty much save them all here. These are just some sample palettes we also gave. So you have generic colors in which you can click on them and add them to your own new palette. So on the left-hand side over here, this is where you can go ahead and create your own palette. So you can go ahead and, let's say, use a color picker. You can select the color here. You can go ahead and add to it, for instance. And something we thought was really cool would be to, let's say you have a picture of your yarn. So you can go ahead and like, let's say you want to upload that image over here, and then you want the exact shade or the exact color. So you can use an eyedropper and go ahead and click on that color. So Derry got some brown yarn, and we can go ahead and add it to the palette. You can also go ahead and click on colors from over here as well. You can go ahead and add these to your palette too. So let's say like we wanted to add a few colors here, and then we can also name and save our palette. So let's say I want to save this, and now we can see it over here. So I'm just going to keep the selected palette we previously had, but let's go ahead and save everything. So everything's been saved. If we go over here, this was the design that was previously created. So it automatically reloads when you like, let's say like open up the program again. So over here is like this little like bird swatch that was shown in the presentation. If you want, you can also go ahead, click on over here on the palette that you're using. You can go ahead and basically click on the grid and change any colors you'd like. But let's say that you didn't like the colors that you had, like for instance, you could like grayscale everything. That was like one of our color palettes we could have used. And like, let's say we want the bird to be like a different color, we want this background to be another color. It could be really difficult to do that on paper. So we have this option to swap your palette. So this is your currently selected palette. Like maybe we want to switch it to our demo palette, see what that looks like. So if I go over here and swap it, all the grid colors change correspondingly in a one-to-one fashion. So this makes things a lot easier to use for knitters. You can also zoom in on this, you can zoom out. You can also go ahead and save this pattern that you've used. So when you reload this, it'll show up. And you can also go ahead and clear the grid. One last thing you can do is also export this pattern that you've created. So let's say you go ahead and click on here. You're automatically able to print it out or save it as a PDF that you can use for future reference. It'll pretty much be this grid that you just saw in the preview. So this was our demo. If any questions, we can also go through at the end, or any other things you'd like to see. We'd love to show it to you. So let's head back to the presentation. So gonna.
Okay, so you might have asked by looking at our program, how did we come up with this solution for knitters? And how would this solution benefit them? Well, we spent a lot of time on research, and we came across a lot of interesting work, one being that of Carnegie Mellon students that we have pictured here. Basically, what they did was create a program for industrial knitting machines that outputted 3D knitted designs. But one reoccurring need that we discovered was that knitters wanted the ability to create and visualize their designs before making them. We also came across a lot of other knitting visualizers or design programs, but they lacked a lot of aspects that our program aims to solve. These include being open source, having complexity of design and choices of color palettes, and also being able to play with the gauge. So we created this program using these following tools. We use Figma to prototype our program and lay out our overall design. We use Electron to create the program as a downloadable web app, HTML to basically create its template elements, and JavaScript and jQuery to create the dynamic elements and give them functionality. We did have some challenges and some future features that we left for future work, like being able to translate and export the design into machine instructions or machine instructions for industrial knitting machines, and also being able to visualize the design as a 3D model. So we wanted to integrate 3D model visualization so that the pattern can be seen on a form. But we ultimately decided to leave that for future work.
Awesome. So in conclusion, we were able to create this web application, and we've learned a lot throughout this process. So we also learned like other things besides software development skills even. So we got to learn how to design and scope a semester-long project. We also got to collaborate on this hands-on project with many other individuals, like with our mentors, with each other, and also like from advice from like the UML Fabric Discovery Center. We also learned about the physical knitting machinery and handcrafting throughout this process. We also, as mentioned, got to expand our software development skills, got to enhance them, and also learn a bunch of new tools and languages, as well as got to play with like Figma and Blender. So the full process altogether. We also got to gain some direction on what our postgraduate goals and plans are, like what exactly are we interested in. We did find that we did enjoy this project, like how it has real world applications, how it's open source, and how it's interactive as a web application. So we'd like to give a few acknowledgements. So first of all, we'd want to give a huge special thanks to our professors, our mentors, Professor Redlich and Professor Downen. They were amazing to work with throughout this whole project. We want to thank Cheryl Gomez, who was a technical program manager at the UML Fabric Discovery Center. She gave us a wonderful tour while we were trying to draw inspiration for the project. We want to thank Red Hat for sponsoring this project, for which this wouldn't have been possible. And we want to thank our audience members for listening here today. On the bottom, you can see some pictures we took from the UML Fabric Discovery Center. So thank you so much, and let us know if you have any questions, and we'd love to answer them.
So there is a question in the chat asking whether or not you can import a GIF or a TIFF image into your program.
Yeah, sure, I can answer that. I think that's something we had in our prototype that we wanted to do. So for the importing image, and that would definitely be a future work step that we'd love to have, in which you could, for instance, import like some sort of image, and then it would pick out like grid squares, or based on how many grid squares there would be, and then basically translate it. You can click on somewhere and place it on, like, let's say this grid, or render it on, like, let's say a sweater. So definitely something we would love to do for the future.
Do you think this is a project that other students would want to continue? And do you plan to make the application available for people to use in some way?
So I can answer that. I would hope so. I would hope other students would continue our work. As for right now, it's open source on GitHub, so it's downloadable through Electron. Like we said, Electron has very simple instructions on how to download it. So basically, if you just copy our GitHub repo and download it using Electron, you can be able to run the program as is. And we encourage any input, any adjustments to make this program even more better. But as of right now, I don't know. I hope somebody will continue it.
Fred Martin has a question too.
Thanks, Heidi. Kelly and Erica, this is so great. I'm so happy to see it. And thank you, Amanda and Paul, for supervising this. When I brought you together, I'm so happy to see this. In your presentation, you mentioned that some of the outcomes are it helped the both of you think about your future career directions. Can you elaborate on that? Yeah, the last bullet item. Like, can you each say how this helped you think about what you want to do next? Kelly,
So
I'll choose you to go first.
Okay, yeah, I can't see the screen, so I can't tell if anyone's speaking. But yeah, for me personally, I think like maybe something I've always wanted to do was contribute to open source code. Like that's always been like a goal. It's like, oh, like you've learned like enough skills and now you can contribute to something that other people can use that's like publicly available. So that could be something that I'd be potentially interested in doing like on the side or for fun or potentially for work too. I think that'd be really exciting. I did find web development or the web application development process here to be very exciting. I've taken the GUI programming courses at UML, but for this one, I got to do something that was more like real world applicable and definitely seeing Professor Redlich, who's huge knitter, being like, this is a really useful tool was really impactful for me. And just working in this team has been really inspirational. So I think like possibly doing more of this like web application type of thing would be something I'd be interested in doing for maybe like in a future career or something like on the side as well.
Thanks, Kelly. And Erica, how about you?
So like similarly to what Kelly said, this project really allowed me to see that I want to go down more of a product design direction. Right now, I'm just a comp sci general major. I'm just taking the general classes. I haven't even taken GUI, so this project really introduced me to front end development, and it basically just made me fall in love with it. Like CSS is such a beast in its own, and like being able to tackle it with this project was so, I guess, fulfilling to say. And being able to use other programs, like I said, like Figma, being able to prototype, seeing a program go from point A to point B and all the way to Z, it was really exciting and I enjoyed it a lot. So yeah, very fulfilling.
That's excellent. Thank you both. And thank you, Heidi, for supporting this project. As the two students said, without Red Hat, this project wouldn't have been possible. Thank you.
Yes, thank you all. That's really interesting. Thank you so much for presenting.
Thanks.
Okay, so we're going to go on to the next student project. Claire Burkhardt, who's been an intern at Red Hat and who's an Emory University student, and her mentor, Tom Ricks, have been working on a security project called Rekor and Koji integration. So Claire, take it away.
Awesome. Thank you, Heidi. Let me share my screen. Perfect. So as Heidi mentioned, I've been a co-op at Red Hat for the spring 2022 semester. And one of the projects I've been working on is integrating Rekor, Koji, and RPM signing. So what we're going to talk about today as a quick agenda, I want to overview sort of the components of the project that I worked on. So that's understanding RPMs, Koji, and signing, and then understanding the Rekor server itself. And then I'm going to talk about the plugin, which is the integration that I created that combined these two systems. And then finally talking about next steps in the developing software signing area. So to start off with, what are RPMs and what is Koji? So RPMs are both a package manager and a file format, and they're used to deploy software packages to RHEL and Fedora. So you can have a .rpm file, or you can do in your terminal RPM install or whatever command you want to use there. So RPM files themselves contain headers that are, you have a lead, your magic number for your RPM file, you have your signature, and then you have a file with index metadata about the package itself. So you have those headers, and then you have a payload, which is a CPI archive of the files being installed. So that's a breakdown of what the RPM file format is. And then if you're distributing RPMs, typically you're going to sign them for security purposes. So if you want to sign an RPM, You can do that using PGP, and the signature actually goes into the RPM file itself. It's stored in the signature header. And then if you take that signed RPM file, you distribute it, and your user comes and downloads it, they should hopefully be verifying the signature before they're installing it on their machine. And so to do so, the user has to go track down the public key that's probably somewhere on the internet. They download the public key, they store it in the local RPM database, which is again that RPM package manager tool, and then they use that stored public key on their system file ring to validate the file signature header. So it's a bit of a process, which is one of the things that motivated this project. And then lastly, Koji itself is the RPM build system that tracks, manages, and organizes all of the RPMs for the Fedora projects. And then there's other instances of Koji that are used for other projects as well. All right, so with that background, I want to talk about Rekor. So Rekor is a sub-project of the umbrella project that is called SigStore, and SigStore is all about software signing and supply chain security. So Rekor itself is a transparency log, which means that it's a tamper-resistant, time-stamped, immutable ledger of signing metadata. So the way that Rekor works is you spin up a Rekor server. There's a public instance of it that's run as a public service. So you're going to talk to that public server. You're going to sign an artifact, and you're going to upload the signed artifact, its signature, and its public key to Rekor. And so what Rekor will do is it'll extract a bunch of metadata, a bunch of information about the artifact and the signature. And then that entry will live in Rekor forever. And anybody can come in and they can query Rekor. So they can get a package that they know has been uploaded to Rekor or is supposed to be uploaded to Rekor. And they can go ask that Rekor server, does this exist? Is the signature valid? What can I know about this package before I download it? So it's important to note that even though Rekor is a security tool, it doesn't prevent the vulnerabilities of using signing keys. So it doesn't prevent private key exposure or identity theft. And it also doesn't ensure that a signed package inherently isn't malicious. But sort of the unique offering that Rekor provides is that it's a chain of custody tool that's external, immutable, and time-stamped. And that it increases trust by allowing individuals to check their signed software against it. So it's external, it's not sort of within the system or within, in the RPM case, it's not within the RPM file itself. It's time-stamped. Nobody can go in and take out entries that they put in Rekor. And again, it's sort of an external source of truth that people can query against. It also streamlines verification and key management specifically for RPMs, which is very valuable. All right, so with that background, what's the goal of my project? So I wanted to, using Koji, have a system where you could store RPM signing materials in Rekor in addition to the RPM signature header. So as I already touched on, there are a couple of reasons why this is valuable. The first is having that external source of truth that has those key characteristics of supply chain security. The second is using Rekor as a first step towards improving just broad chain of custody and traceability within knowing where your software comes from, knowing who's had access to it, who's made changes to it, who's signed it, and then also simplifying verification on the user end, because the more simple verification is, the more likely it is to be used. So how does this work? So what I did is I created a plugin that is installed into Koji. And this is an outline of the workflow for what it would look like to sign an RPM package and then to import it into Koji. So let's say you have an RPM package here at the top and you need to sign it. So the way that you do that is you take the package and you call RPM sign, and RPM sign will grab your GPG information that's stored locally and it'll sign the package. So then you have this produced here. So now you have to get the signed package from your computer or from wherever you signed it into Koji. And so there's a command that's Koji import sig. And what this does is it splits out the signature header from the signed RPM, and it uploads that signature header to Koji, where then that header is stored in tandem with all of the other RPM build materials that Koji has already stored and organized. And so the plugin happens here. And so it is this red dashed line partition is the new functionality. So while Koji imports sig, sends the signature header to Koji Hub, which then goes into the server, the command also sends signing information to Rekor. So it takes that file, that signature header, it grabs in the public key from your computer, and then, or your system, or whatever it is you're using, and then it uploads all of that information to the Rekor transparency log server as well. So now you end up with signing material stored in both Koji Hub and in Rekor, which again is the goal. You should be able to check them against each other. So the plugin uploads the RPM file signature and metadata into a queryable Rekor server. And when I was creating this, one of the reasons why I decided to make a plugin is because it was really important to enable both functionality and policy enforcement. So what that means is that you can configure within the plugin whether a successful Rekor upload is optional or required for the Koji action to succeed. And you can also configure where the Rekor goes. So it can be to the public server or to a private server that somebody else hosts, depending on your workflow. And I want to run through a quick demo of how this works. So in this system, Koji is already set up, and we're going to download a PGP build onto our system. And so we can see that we have a couple different RPMs with different architectures downloaded, and we're going to list which ones of them are signed. Oops, I restarted the video. Brilliant. Okay, so we're going to list which of them are signed, and we can see that this IA64 architecture isn't signed within Koji. So what we're going to do is we're going to take this file that we have downloaded, and we're going to sign it. And we can check and make sure that the signature is valid. So we can see here that both the header and the package itself have been signed. And so now we're going to call that command that's Koji import sig. And so between these two lines here, your Rekor entry gets uploaded. And so you can check the Koji logs and see all of the information that Rekor spits back at you when you do an entry. It's a bunch of stuff encoded in base 64. But really what you want to do is say now that you're a user who has this package, you can search using the Rekor command line for the artifact within the public Rekor log. And you can see that because we've just uploaded it, there is now a matching entry that matches this signed artifact. And then you can take the UUID of that entry and you can use that to get the entry and get more information about the package. So again, we're querying the Rekor server to get this specific entry. And we can see in that a bunch of information. So we can see an information about the log, the index, when it was uploaded, and then about the RPM itself. So its hash, its headers, its release version, as well as the public key that is at the end. And so you can use this public key to monitor as well who's been uploading your public key. So the Rekor log is variable by public key in addition to being variable by artifact. Okay, so what are next steps for this project? Well, the first next step is just integration. So it's integration for developers using Koji or an instance of a Koji system, and then integration on the user end, where the goal is that more RPMs, when they're distributed, are put into Rekor. And so then users should be using Rekor to validate their software before they're downloading it on their computer. But then beyond that, there's a lot of work being done right now in supply chain security for developing similar tools and then integrations with systems like Rekor and SigStore and similar projects that are aiming to achieve these goals of better supply chain security. And so those goals can fall, there's a lot of goals, but some of the most important ones and ones most relevant to this project are full traceability. So in the ideal, you have a full record of like every stop your package has made from the beginning of its build process to when a user downloads it on their computer. Distribution and signature monitoring. So users or developers who are using private keys to sign artifacts should be able to monitor when their signatures are being used, which again, you can do through Rekor. And then streamline user end validation. So at best, you want user end validation to be ubiquitous and automatic. We're nowhere near there right now, but that's the goal to move towards, because again, the easier it is to validate, the more likely people are to use it. And so security needs to be as user-friendly as possible. All right, so I want to conclude with some shout outs to Luke Hines, Yesenia, Tom, and Heidi for all their support and mentoring, both on this project and then also with my time at Red Hat broadly. I really enjoyed working on this and working with all of the amazing people at Red Hat. So thank you all for the support and opportunities. So I'm happy to answer any questions, and I see that there are a couple in the chat. How do you ensure that the Rekor server data is not manipulated? That's a great question. The way that Rekor servers work is they use Merkle tree hashes, where the sum total of all of the prior entries are hashed, and then the entry that is added includes that hash, which is the unique identity of everything that preceded it. So if you come back and you try and take an entry out of the Rekor log, or you try and change even one small part of any prior entry, it'll screw up the entire hash chain, and so your validation won't work. And so on the public server, there are a ton of separate groups that do log monitoring. I think Purdue University was a founding partner, so they do a lot of that. And then there are tons of groups that do this. And so by monitoring the log and having records of those chains, you can make sure that all the entries are valid from root to the most recent entry, and it's all based on Merkle hashes. And I see another question about the threat model. So what kind of attackers are you defending against? So basically, Rekor itself mitigates attack vectors where signatures either packages are distributed and are unsigned, so nobody knows about this. Where you have packages that are signed, but nobody checks them because it's a pain to check, which is a particularly poignant problem with RPMs. Or attack vectors where malicious actors have access to private keys and are wreaking havoc, but you don't know that because you have no entry of when your private key has been used to sign something. So if you have a workflow where you only download a package, even if it's been signed, it has to be signed and in Rekor, then you can monitor Rekor and know exactly what packages are being distributed. But again, Rekor doesn't mitigate attack vectors for Rekor server itself or just like typical signature vulnerabilities. Did that answer those two questions?
Yes, that did. I think the Merkle tree is still an issue if I can manipulate the entire server, but I think this attack vector basically says that's out of scope.
Yes. The Rekor project itself has more documentation about what they're doing to stay away from that. I know they've been doing a lot of work with monitoring, sharding databases, all of that. So it's definitely an issue because you want to make sure you trust your security tools, but that's what the project is dedicated to working on and fixing. Did anybody else have any other questions?
I think that does it. Thank you very much, Claire. That was a
Awesome.
great presentation and great job of making a complex topic understandable. Really appreciate that.
Thank you.
Our next presentation is from Aman Batra from Northeastern University. His mentors are Gagan, Kumar, and Tzu-Mainn Chen from Red Hat. And he's going to speak about Elastic Secure infrastructure capabilities and extending them.
Hello, everyone. I hope you can see my screen. Okay. So just a second. Yeah. So my name is Aman, and I'm a software engineering co-op at Red Hat. I work with the ESI team, and today I'm going to present a part of what ESI does in my project. So the agenda is pretty brief. I'll introduce myself, I'll talk a bit about ESI, and then I'll discuss my project. So I very recently graduated from Northeastern University. I have a master's of science degree in computer science. My specialization was cloud computing and data science, and right now I'm doing my co-op with Red Hat. So now coming to ESI, it's a fact that machines don't get tired like humans do. So why let bare metal servers sit idle in data centers, when we can do so much more with them? So for that reason, ESI exists. So ESI is a service that enables building a bare metal cloud, which is designed to be used by multiple tenants. Now these tenants can either be a single organization which owns all the hardware and wants role-based access on these machines, or it can be multiple organizations who just want to pool their hardware together. So ESI owners have exclusive rights to their hardware, and they can lease it to the interested parties for a predetermined period of time. So ESI builds on top of OpenStack services such as Ironic, Neutron, Keystone, etc. To sum it up, ESI can be thought of as a specific configuration of OpenStack services. So how does ESI work? Uh, Basically, there are three roles in ESI. There's an owner, a lessee, and the admin. So owners can be thought of as admins of maybe a single node, a group of or a group of nodes which belongs to them, and they have privileges like admin rights, and they can create offers and sign leases. Owners can view their only their machines, but not all the machines. So that is how an admin is different than an owner. Admin can view all the machines, like uh, so now an owner, they can draft leases for their bare metal nodes, and they can set a period of time and release an offer in the pool of offers. So then the tenants, the lessees, they can pick a machine of their choice from the pool of available offers and for the time span that they want, and they can sign these leases which are created by owners or admins. uh, and lessees can use the machine, utilize bare metal cloud for their use cases. So what's different in an owner and lessees, lessees do not have all the privileges. They get a basic set of privileges, like they can turn on and off the machine, and they can they can utilize the machine for their use cases. So let's see what happens behind the scenes. So there's a policy file I just mentioned. It's an ironic policy file that controls the node APIs, which an owner or a lessee can and cannot use. So this API file can be manipulated. If I want to fine tune permissions for a lessee, let's say I do not want a lessee uh, controlling any power state or anything, we can do that as well. Then we can enable lessee to uh, do something else. And basically the permissions by default, it's like this. So admin have all the rights and they can view all the machines. Owners have all the right, but they can only view their machines. And lessees, they cannot, they have the least permissions and they cannot do that much. So they're limited to just their machines. So before I proceed further, I assume that you have a knowledge of how a bare metal server differs from a virtual machine. So when it comes to bare metal machines, security can get a little bit tricky, which is where my project comes in. So my tasks were to detect and investigate general and privacy concerns and security concerns around ESI bare metal cloud. Then I tested and researched some functionalities that can aid in recovering, rescuing a node, or maybe cleaning them, like just recycling them after every workload. And finally, I try to look for ways to prevent certain actions that can compromise a node beyond recovery. So for bare metal nodes, the security issues can originate either externally or internally. External, there can be attackers, there can be denial of service attacks or a ransomware attack or anything like that. And then there can be internal issues such as a lessee node getting compromised. So it can cause a lot of security issues, which is where I try to help. My project mostly deals with these internal issues and not the external ones. So I've tried to create a mini roadmap of sort, what are the things that can be done and how to detect some of these issues. So let's talk about the issues first. Now there can be issues with more specifically lessee nodes. So a lessee may be able to misuse or compromise a node by excessive overclocking of the CPU or the GPU. Now this can induce a lot of like heat in the system. So heat is not good for hardware, and it can like reduce the lifespan of hardware, or probably like kill a CPU if it exceeds a certain limit. And so in long run, it can impact the hardware in a negative way. Now second thing is swap disk usage. So what swap disk basically means is when we use hard disk as an alternative for RAM. So we are doing all the RAM crunching using our hard disk. Now what happens is when we do this, it causes very high input output cycles, and hard disks have a very limited lifespan. Like so, if a lessee is like engaging in swap disk, they can like impact the hard disk as well. And then lessees can use nodes for like unintended purposes like cryptocurrency mining and the like activities that can put a lot of stress on CPU or GPU, which can again decrease the lifespan of the chipset. Also, in case a lessee machine gets infected without their knowledge, they might even launch an internal DDoS attack, or low intensity DDoS, or maybe a brute force attack to other machines on the network. So uh, this is another possibility. Besides that, like there's a chance if a lessee willingly, like intentionally or unintentionally modifies system firmware. For example, they play with like BIOS settings, then their actions may cause a node connection or a node failure beyond recovery. So we need to keep a check on these things. Now, detecting these issues can be a problem. So for example, I can run a regular network connectivity check on lessee machines from owner nodes or admin nodes to make sure there is no connection loss. It will mean like the lessee node is still connected. But how do I verify if something is going on a lessee node? How can I track the usage? Like it's difficult to track what goes on a lessee machine without any sort of privacy invasion. So this is where like there's a method that I figured out recently. It was research and it has been like implemented by another group of researchers, and it's an open source project. So what they did was like they were constantly monitoring node sensors for any suspicious behavior, like readings from uh, the nodes. Basically, I will talk a little bit more in the next slide. I think it's not there. Yeah. So what happens is if I have like readings from sensor, it can be CPU voltage or like fan RPM, or it can be like core temperature. So by inferring certain statistics from these and observing these for a longer time period, I can like rule out some patterns like malicious behavior, or maybe CPU is being overused to an extent, like it's the voltages are always high and the core temperatures are always like rising. So we can get some insight on what is going on in the machine. Like we cannot directly observe what LSC is doing because they have like all rights to the bare metal node. So this is the need for like there is a need for these non-invasive methods. So there was another thing called package streamer which I explored, which can monitor traffic patterns to a bare metal node, and like it has certain predetermined patterns. If like the network traffic usage matches with those patterns, it can be like figured as suspicious behavior. So that is another thing that we can do, like monitor traffic to a particular node. Now then I moved on to node rescue and recovery measures. So when looking for ways to recover or rescue compromised node, I went through some services that were already available in the Ironic API, like which we could probably leverage for security and cleaning purposes. So first thing was a node rescue operation, which I tested and confirmed as working. So basically, any admin or owner can try to regain access to like a compromised node using Ironic's rescue operation remotely. So unless there's something big like that's been messed up, for example, if the Pixie driver has failed, or there's some kind of firmware issue, like some one of the firmware is corrupted, like while flashing a firmware it got corrupted, in which case we may need a physical visit to the data center. But for most cases, the rescue mode works fine. The second thing I stumbled upon was Ironic's node cleaning service, which can do more than just cleaning. So one can import or export drivers, fix or restore corrupted firmware. They can restore BIOS to a predetermined setting, like a good state. So that was another thing that existed. Because ESI builds on top of Ironic, we were able to leverage these features like they are already existing. So these were a couple of measures that I found useful. Then, so how to protect nodes? Like the first thing is we should protect nodes from certain activities. So let's say I'm an admin or an node owner. So I can probably put some firewall rules in place. I can have a software firewall. Maybe I can install some anti-malware tool or third-party monitoring tools. But if I want to monitor what goes on, like on the lessee nodes, which I have leased to people or like parties who are interested. So for that, I cannot do much. Like I cannot install anything on their machines. It's like out of the scope. It will clearly mean like invasion of privacy. So for that reason, we came up with some things that can be avoided. Like one of the things is resetting node drivers or BIOS. So lessee should not engage in any kind of like uh, activities that can reset node drivers such as iDrag driver or BIOS. And another thing that can be done is we can avoid using the same password across the machines, like for BIOS or for iDrag. So that way, if one machine is compromised, we can at least like protect the other machines if there's a like attack coming from one machine to another machine. So once the user base for ESI expands, I think more and more concern will be explored and more security measures will be put into place. But for now, this is the outlook security side of things. And what's next? So ESI is undergoing multiple improvements and testing as we talk, and the future is quite exciting. And like currently a lot of testing is going on, and once ESI is deployed in production in MOC, we will be able to figure out many more things such as potential for different use cases, uh, required optimizations, maybe bug fixes and places where ESI needs more work to be done. And successful implementation of SSO-based authentication and external authentication may also be around the corner. Maybe a front as and like a front end as well in future. So that's it for the ESI. So that's pretty much it for my presentation, and I will like I'm open to questions now. Okay.
Thank you, Aman.
Yeah, I think
I'd
we're
like-
running short on time.
Yes, we're running a little short,
Yeah.
so
Yeah.
we'll have to
Okay.
proceed to the next presentation.
Okay,
If
sure.
anyone is interested, certainly you can contact
Yeah.
them.
So you can contact me for any questions.
Okay, our last presentation is by Brian Montalvan on Operate First open source web development. And his mentor is Leo, and Brian is another UMass Lowell student. Thank you. Go ahead, Brian.
One second. Hello, everybody. Give me 1 second. I have so many tabs open. I'm copying you, Heidi. Let me know if you can see my screen.
Yep.
Awesome. Okay. So hello, everybody. My name is Brian Montalvan. I am a current spring software engineering co-op here at Red Hat. I will fly through these slides because we are very short on time. So basically, I'll start out with a brief introduction about myself, a very quick intro to Operate First, and then what my project consisted of. So who am I? My name is Brian again. I'm a sophomore at the University of Massachusetts Lowell, originally from Florida. A cool fact is that I worked / was a part of a summer bridge program sponsored by Red Hat, which exposes incoming freshman CS students to various technologies and much more, which was ran actually by Fred Martin, who's here in this meeting. So big shout out to you, and also big shout out to Hattie as well for making things work in that end. I currently work at the Operate First operational group and the community group. And these are some hobbies and interests that I have. So let's get straight into it. What exactly is Operate First? So Operate First is a concept to incorporate operational experience into software development by extending development to include testing, improving code and production environment. What exactly this means is that basically Operate First is an open source initiative which allows developing software to come onto a production cloud environment. Right now, we're specifically tailoring for more so data science. So data scientists can bring in their models and come on and test in our environment, which has a plethora of services and workloads specifically meant for data scientists to come on and test their models and their applications. Currently, we have some bare metal servers, specifically the MOC, which is the Mass Open Cloud, or Massachusetts Open Cloud, which is basically ran by an alliance of academic institutions, medical centers, or medical institutions, and also the industry, which includes Red Hat ourselves. If you want to learn about Operate First, because it's an initiative, it's not a project, it's huge. It's a huge umbrella of a plethora of things. So my biggest advice is to go to our YouTube channel to see live demos of what exactly goes on. There is constant data science meetings that we have, and just checking out our documentation, our blog, our Slack channel, etc. if you really want to get a deeper dive into exactly what is Operate First. So yeah, so we'll be just briefly explaining what it is, as I have been also a little bit more tailored towards the website side of things. So my project is basically kickstarting a website. So basically, as the description says here, it's creating a new website from scratch as a community racing against the clock. So the context of this is basically, in my co-op, I actually had another project, which was basically monitoring / visualizing storage on our Operate First clusters. But since I have a web development experience / background, I joined in to basically help out whenever I saw any open issues on the Operate First website repository on GitHub. I would try to do some on my spare time, just because I enjoy that. Eventually, the community decided to form a working group, a SIG formed working group. I'm not the best at explaining what exactly a SIG is, but basically it's just a working group with a goal of improving the website. So people coming together with the same goal and hopefully achieving it. So the initial goal of the group was to basically add on to our previous website, so making the user experience and the content more streamlined. However, as a collective, we decided to scratch that and to make a website completely from scratch. So since we're on the clock for deploying, there's a good amount of pressure because we decided to start a website from scratch about a week and a half before KubeCon. KubeCon is a Kubernetes convention. So basically, we decided to start a new website from scratch right before we wanted to show it and deploy it for KubeCon. And thus, our goal was to make a presentable and streamlined new website for KubeCon, and obviously beyond the event. It's not just for KubeCon. So basically, what we did was we decided to just discuss what we wanted to see on this new website. We discussed what we didn't like from the previous website, what we wanted to scratch, and what we didn't want to bring over. We also discussed just the layout and structure of the content on the website, just to make it more concise. So that way you're not constantly clicking around links to figure out exactly where you are, and just being able to just digest information and content better. So basically what we did was divide work among contributors, which is one of the main things. And to the right here, there's a little diagram of our Miro board, which is basically just a diagram of kind of like how we lay out the content of the website. And as for the technical steps, we decided to start out with a fresh new project, specifically using Gatsby. So it was just completely brand new. If you go to Gatsby, if you go to their docs, that's literally all we did. We just created a clean new Gatsby JS project with their file structure and just completely from scratch. We decided to use a UI component library called ManTeam. It's a React-based UI component library. And then using that, we were able to just start out and just start creating the new structure, whether it be the homepage, routes, and then we had to really focus on exactly how we wanted to implement, because we created the Miro board, we created the visuals and the diagrams of how we wanted things to be shown, but actually putting that into code, it's a different story. But luckily enough, we're able to do that. So here is the original mockup I created. Because at first we're kind of on standby as to how we wanted to kind of create the website. And I was like, well, how about let me just introduce a new library and let's just have something visually to work upon on. And that's exactly what I did. And people were like, people on the contributors who I was working with, they were like, this looks good. Let's go with it. And that's pretty much what we did. So through Slack and GitHub discussion, we were able to collaborate and create a new content-filled website just in time for KubeCon. Literally the Thursday before the Monday that KubeCon started and the Monday that we presented. We deployed the website. There's still a little bugs here and there, but I was able to get some stuff going along with other people throughout that weekend beforehand. And we were able to have a presentable website for KubeCon. Here's a little bit of a few screenshots. I'll be posting the link. If you just type in Operate First on Google, and that's the first thing that shows up is the website. So you can take a look now if you really want to. One of the big things was Tom Kaufel was presenting at KubeCon, and he showed a screenshot of the Operate First website. And it just meant a lot to me, just seeing kind of our work and our contributions together as a team just show up on the big screen. That was definitely one of the most rewarding aspects of it. And here I just wanted to kind of like bounce off what I kind of presented at my previous presentation, specifically for Red Hat, my final co-op presentation, which is basically, why does this project matter? So basically, reworking the Operate First website was integral to the initiative as a whole, since it's the front face of what the initiative is about, along with what the first piece of content that people will see. Typically, when you want to learn about something, you go to a website and see what they're about, whether it be Kubernetes, whether it be Docker, whether it be some sort of library. So having a concise and streamlined way to deliver information and resources is key to retaining and getting users, which is something we heavily discussed before we even thought about creating a new website from scratch. So the goal for the website was simply just to get the ball rolling. So here, we have, this website isn't too fancy. We had 0 UX design employees or anybody with that experience on deck. So really, it's just a bunch of engineers, a bunch of people who just had experience just coming together and making a website happen. So the goal, hopefully, by a few months now, I can just go back to the website and see it looks amazing, it looks beautiful. So the goal really was just to create that seed and for it to grow. So what was completed? We were able to deploy it before KubeCon, and also we just kind of got the ball rolling, so now the website can be expanded and be worked on. The biggest takeaway for me was working as an open source community on the website was amazing, because just working with people, not even just as Red Hat employees, but just as developers coming together, whether it be just drafting new ideas, discussing new ideas, requesting changes on each other's PRs. There's a few people who came on. Sorry for the background noise if you hear that. There's a few people who came on and said, "Oh, this is a cool library. I might use it for my own project." And it was just nice to have that feedback between the community and just colleagues ourselves. So it was definitely something that made me more passionate in open source itself. And that's really about it. We're out of time now, but thank you for watching. Feel free to reach out or connect with me on LinkedIn or my work email here. And I'm more than happy to discuss anything and everything. So thank you.
Wow, good job coming in on time, Brian.
I try my
amazing.
best.
I'm sorry that your talk got a little compressed there.
Oh no, it's perfectly fine.
So I hope you guys were interested in seeing the breadth of things that are done on the front end and the back end and security and in the middle. We're always interested in having new students working with us and new professors and researchers joining the rig. So please, if you're interested in any of this stuff, reach out, come to our next meeting. They're always on the first Tuesday of the month in this time slot. So hope to see some of you again, and thanks for being here. Oh, and Brian put a link to Operate First Cloud in case you want to see more detail. And you're all welcome to participate in that project as well. So Jen, if you want to stop recording. Yeah, thanks everybody. This was really great session.